Hey, welcome to another problem session. So today we're continuing to do the JEE 2024 Advanced Physics Paper 1. So here is the problem. Now, I should say that when I was reading this question, I was a little bit confused how things were set up. But it's very clear to me after a couple of readings, and that's probably not very good during the exam time. So rather than show over there, I will show you over here. What happened is they put a motor over here, and to that motor you can say they attached a disc, this disc. So initially everything was at, say this is t equal to 0, everything was at rest. And let's make it a little bit bigger here so it looks similar to that. So everything at rest, but this motor is actually attached to this structure, okay? So this attached to that structure. And turn the motor on, maybe, there is somehow there is a mechanism to turn the motor on. You might say there was a wire and you turn the electricity on, or it's remotely just remote control motor. But that motor, when it turns on, is going to say spin this guy this way. Say let's spin that way, other way around. So you spin it that way. So you start to spin this way, then the angular momentum will be, if you right-hand rule, will be up, right? So angular momentum will be up. So maybe I can illustrate the angular momentum will be up, and so the other disk will rotate, so this angular momentum will be down. So let me show you what the other is. So this will rotate this way at time t. If it's going this way, then this other guy will go that way. It's like this disk. This disk will start to go around like that, along with this larger disk. And while it is rotating this way, okay, while it is rotating this way. So let's see if the up is a plus sign, then this down for angular momentum, this angular momentum vector for this guy will be negative sign, and when it's going, this guy going around will, as a mass m over here, there will be negative sign. So at t equal to 0, angular momentum is 0, and at some time t, where these things is given, this guy is rotating this way, so this guy's angular momentum will be L of rotation of, let's call it A and it's called B. Rotation of A will be positive I of A omega. And then also we have the center of mass, L of A, center mass of A, and circular motion. So it's going around circle, and that's its angular momentum will be just the entire m at the rim. Excuse me, m r. This rim is, this distance is r square times going around this omega over n. This going around, this thing is omega over n, and this thing is going this way with omega. And then this disk, but this will be a negative sign. Why negative sign? Because it's pointed down. If you do a right-hand rule is going to be pointed down. So but LB is a disk, and it's going to be, its rotation will be negative IB omega over n. Now these three have to add to 0, so let's see what IA is. IA is going to be about this axis, so half m r over 2 square is 1 over 8 mr square, and IB will be this big disk, and it's going to be half mr square. Now clearly we're using these guys must equal to the same as the t equal to 0, so L at t equals to L at t equal to 0. This is the total. This gives me equation 1/8 mr square omega from this guy minus mr square omega over n, and this is minus half mr square omega over n. That's equal to 0, and of course we can just erase all the mr squares from everybody and multiply by 8. So this is 8, and this becomes 4. So what do we have? We have divide by omega everybody, 1 minus 8 over n minus 4 over n, 0. So 1 minus 12 over n is equal to 0. So this just means n equals to 12. So this is 12. It's a pretty cute problem in the end. Okay. All right. That's for this problem. Where is the bottlenecks in the problem? So maybe you may have difficulty seeing this, that you have to take into account, because this thing is also going around. So when you have an object going around, you just place all the mass at the center of mass, and then you just do I. If you have something going in a circle, a particle of mass m and some radius r, then its moment of inertia is simply mr square, and it's going in a circle with the same omega as omega of this large disk. So that's probably a bottleneck. Other than that, it's pretty straightforward problem. All right, take care. Bye.